Shall we start, sir, with your permission?
Yeah, sure. You can start.
Yes, sir. Thank you. So, hearty welcome to Dr. N.V. Umamahesh Garu, Professor, HAG, National Institute of Technology, Warangal, and all dignitaries and participants present over here. So, he is going to give lecture on sustainable urban water management. So first I request Sudhir Kumar, Assistant Professor, Department of Civil Engineering, Sri Vidyanakar Engineering College, to introduce our guest of speaker, Dr. N.V. Umamahesh.
Thank you, sir. Good afternoon, all. So it is my privilege to introduce Dr. N.V. Umamahesh Garu for the current session. So Dr. N.V. Umamahesh is a professor at the Department of Civil Engineering, National Institute of
Voice is low.
Okay, sir. National Institute of Technology, Warangal, India. He had received his PhD degree in optimal planning and operation of irrigation reservoirs under multi-crop environment from Regional Engineering College, Warangal. Right now it is NIT Warangal. And Master of Technology in Water Resource Engineering from Indian Institute of Technology, Kharagpur, India. He had received Best Engineering Faculty Award 2017, presented by National Institute of Technology, Warangal and NIT Warangal Alumni Association. Best Paper Award for the paper presented in International Conference on Modeling Tools for Sustainable Water Resources Management held at IIT Hyderabad in December 2014. And State Level Jalmitra Award constituted by the Government of Andhra Pradesh for successful implementation of watershed project in March 2003. Professor N.V. Umamahesh has more than 25 years of research, teaching and consultancy experience in the area of water resource engineering. He was teaching postgraduate level courses which include water resources systems, planning and management, engineering hydrology and hydrologic systems, computational methods, applications of soft computing techniques, stochastic hydrology, etc. Professor N.V. Umamahesh has had guided more than 100 MTech theses, 11 PhDs, and currently guiding 7 PhD students. He had published 45 papers in international journals, 5 in national journals, and 50 in national and international conferences. He had organized 2 international conferences and 6 workshops, short-term courses. To his credit, he has completed 4.48 crores worth research projects funded by the DST and UGC, etc. And 1.17 crores worth research projects are in the pipeline. So with this, I will stop. So I request Dr. Yamari Prasad sir to take over the session. Thank you so much, sir.
So thank you, Dr. Hemal Prasad Rajgaru and Dr. Sudhir Kumar for the nice introduction, and also for giving me this opportunity to interact with the participants. It's always a pleasure to be associated with Vidyaniketan. I think I've been associated with Vidyaniketan College of Engineering since long time. For a long time, I think for a few years I was a Board of Studies meeting member, and then I think I used to attend the Board of Studies meetings. In fact, 2 of my students are faculty there, Dr. Iswar Reddy and Dr. Vinay. And so it's always a pleasure to be associated with this institute. So let me start with presentation.
Your PhD student also is working here, sir, Dr. Vangari Vinay Ashok.
Oh, that's what I said, Dr. Vinay. Yeah, Vinay was Vinay. And Iswar was long back my student, Iswar Reddy.
Yes, sir.
I hope he is also there here.
Yes, sir.
Yeah.
So your 2 students are here. One is a professor and HOD, another one is assistant professor, sir.
Yeah, yes.
He wanted to see, but he has got class. He gone to attend class, take class.
Okay, fine. Yeah, all right. So let me start my presentation.
Yes, sir. Thank you, sir. Yes.
Hope my screen is visible to everyone.
Yes, sir. Yes, sir. Yeah. Go ahead.
my talk on today will be on sustainable urban water management under changing climate. You all know that in fact the climate change is in fact causing more stress in water resources, and especially more in the case of urban areas where you have the water demand and the wastewater generated are going beyond the limits. So that's just an overview of what I'm going to talk today. So I just try to briefly uh, talk about the global water resources, and then how the water and sustainable development related to each other, and in general, what are the impacts of climate change and water resources. And then we take up the urbanization and the challenges posed by urbanization. And then I'll start my main topic where I'll discuss various components of urban water, and then what are the present practice of urban water management and how they make the urban water management more unsustainable. And so we'll then discuss about the concept of sustainable urban water management, and then what are the various approaches for sustainable urban water management. So let's start with just a brief review of the global water resources. So So if we just take the total water available across, over the entire world, maybe you can see that the freshwater resources are just only 2.5% of total amount of water resource available. And in that, say almost say 30.8% is available as deep groundwater or soil moisture, swamp water, which can be used directly by us. And then around 70% to 69% is occurring in the form of glaciers and permanent snow cover. So what is useful for our activities is just only around 0.3%, which is the form of lakes and river storage. And obviously, this is not said, though this is just only 0.3%, this is considerably a large amount. In fact, I given these values in kilometer cube here. But the problem that we have here is this water that's available is not uniformly distributed both in space and time. And that is what the major issue for us many times, because we don't have water at the required time, in the required quantity. Okay. So only this portion of the water is useful for us, like as I mentioned already. In fact, most of this water, other water is saline water or brackish water. What we call as saline water is where the concentration of salt is between 10 to 100 grams per liter. Whereas if it's 1 to 10 grams per liter, it's called brackish water. If the amount of salt present in this water is less than 1 gram per liter, we consider that as fresh water. This is a hydrolysis cycle where I'm showing various components of this hydrolysis cycle, and then the values. Like for example, this runoff is around 119 billion kilometer cube. In fact, sorry, all these values should be kilometer cube. I'm sorry, I think some places it's written as kilometer square. So the precipitation is 110,000 kilometer cube, and the precipitation occurring into the lakes is around 9,000 kilometer cube. So groundwater flow is 2,000 kilometer cube, and that's how you can see the different components here. And in this, what we are interested is the river runoff, which is around 42,600 kilometer cube, and the groundwater flow, which is 2,200 kilometer cube. So these are the two sources, freshwater sources, that we can actually use for our human activity. So that we can consider these are the principal sources, which amount to around 44,800 kilometer cube per year. So 44,800 kilometer cube per year, as I said, is a considerably very large amount. The only problem here is that, as we'll see later, this water is not available uniformly with both in space and time. Okay. This is the global water demand. If I look at the demand of water, for different activities like agriculture, municipal, industry, power generation, and primary energy production. Means what I mean by primary energy production is other than the power generation. So these are the various activities for which, and if you look at the demand, withdrawal and consumption. Please note that there is always a difference between the amount of water that we are withdrawing from a natural water source and what we are consuming. So in fact, this ratio obviously indicates the efficiency with which we are actually consuming the water. So the amount of water that we are withdrawing in 2014 was around 4,000 kilometer cube. In fact, when you say 44,000 kilometer cube per year is what you have, 4,000 obviously is around 10%, but the question is that from where we are drawing this water and what is this is spatial and temporal distribution. So by 2040, cycle will increase slightly to more than 4,000, and the consumption is increasing. So we expect that, in fact, the ratio of the consumption to withdrawal is actually also increasing because we assume that our applications become more efficient. And you can see the major part of this consumption is withdrawal or consumption is for agriculture, and the next part is municipal industry part. So these two are the major activities for which we draw the water. So in fact, my focus today will be on this part, the water that we are supplying for municipal water, because I'm going to talk about the urban water management. Okay. Now, this indicates, in fact, a different type of graph here. We can see that, in fact, this talks about physical water stress. The sense that it is actually talks about in fact, how much water you are withdrawing and based on as a percentage of total water available. Okay, so if you look at it, say, in fact, most of these South American countries and then Canada and many of the African countries here are in this blue shade, which is just the stress is only 0 to 10%. That means these countries are withdrawing only less than 10% of the water available. So as long as your withdrawals are less than 10% of the water available, maybe you can say the stress is not significant. It's not stress is in fact sustainable. But as the amount of water that you're withdrawing out of the available water sources starts increasing beyond 10%, the consumption becomes more and more unsustainable. So now the entire country, India, falls under this category, 25 to 70%. So already we are reaching a level of unsustainable consumption of water resources based on the availability. Okay. So this is, in fact, most of these Asian countries, India, China, and then the other Asian countries here, and some part of this Mexico and South Africa. These are the countries which are highly stressed in terms of the water consumption, and some of the North African countries and these Gulf countries. Okay. So based on, in fact, we define other kind of stress, water stress, based on the human consumption and the population growth. So earlier stress I talked in terms of the percentage of available water that we are withdrawing for our activities. Now, if we look at for example, the bare minimum required for domestic consumption, it can range from somewhere between 100 liters per person per day to 600 liters per person per day. Obviously, this depends upon your, say, in fact, living standards. Maybe, for example, in India, in most of the rural areas, we can assume that the domestic requirement is around 100 liters. In fact, we even don't design for 100 liters, we actually design for 40 liters. But in India, mostly we take around 100 to 135 liters per person per day as a design requirement when you design the water supply systems in urban areas. But okay, depending on the living standards, it can vary from 100 to 600 liters per person per day. Or in terms of per year, we require 40 to 240 metric cube per person per year. And assuming that other requirements are around 20 times this requirement, so 20 times 40, so it is 800 metric cube per year. So 800 plus 40 to 800 to plus 240, that means the total requirements, bare minimum requirements, I'm talking bare minimum requirements for any, say for a society, can range somewhere between 840 metric cube per person per year to 1040 metric cube per person per year. So this is the requirement. So now let us compare this with the water availability, per capita availability of water. So if the per capita availability of water falls below this range, obviously it becomes stressful. There's a water stress. Okay. So this map shows the stress in terms of this, in terms of the per capita water availability. You can see from 0 to 684,000. So in fact, many of these countries have very, very large water. In fact, these countries have less population, especially America, Canada, and this Russia, Australia. The density of population is very less, but they have plenty of water sources. So the per capita availability of water is very, very high. But if you look at these three categories here, if the per capita availability is less than 1,000 metric cube per person per year, then we consider that region to be to have a scarcity. So these are the countries which are have a scarcity of this. 1,000 to 1,700 metric cube per say person per year is say in fact is considered as stress, water stress, and more than 1,700 or less than 2,500 is vulnerable areas. So I find that we come under the category of stress. In India, in fact, our per capita availability is in this range, the 1,000 to 1,700. That means we are just reaching the condition of the bare minimum requirement for a, say for a society. Okay, and if you look within the say country, in fact, say we can say India is moving from a stressed nation to a water scarce nation. In fact, here this picture gives withdrawals for available supply. So you can see most of the country is either dark red, which is extremely stressful, where the withdrawals are greater than 80%, and many of these parts have high to medium, say withdrawals, say when compared to in terms of available supply. And okay, maybe at least only few pockets at least are low. Some of these pockets. Otherwise, most of the country, you can see that it is under either extremely high to high stress, water stress. And I saw the per capita availability, water availability in India has been changing over the years. And this is how the population has been growing. So as our population increases, at the same time, maybe our living standards are also increasing. So both of these are contributing towards, say, water stress in our country. And the per capita availability as of by 2050 is expected to reach around 1140 metric cube per year per person. As on today, it's something around 1400 metric cube per year per capita per year. So this is the status of our water sources as on today. Okay, and if you look at the say withdrawal in terms of sector as well as in terms of source, we find that 94% of the water that is being withdrawn is for irrigation activities, 7% for municipal consumption, and just 2% for industrial needs. Whereas in terms of sources, I think 52% of the total water being consumed is being withdrawn is from withdrawing from surface water. Groundwater contributes to 33%, about 33%. And maybe desalined water is very, very less. It's negligible. And sometimes, okay, we may use the direct agricultural drainage water, means return water from the agricultural activities also can be used for various activities that come some amounts to around 15%. Okay, so with this background, I just wanted to give a picture of what is the water resource available across the world and with specific difference to India. So we know that we are already reaching a kind of situation where we are becoming more, there's going to be more and more water stress. And maybe certain places may reach a point where, like I think many of you would have heard about the situation that happened a few years back in South Africa and Cape Town, where they could not get the water, say there's acute shortage of water. In fact, I think our Indian cricket team was present there, and they were staying in a 5-star hotel. They also had to get water only in buckets, and that's the situation that they had. And maybe if we continue the same way that we are developing the water resource today, I think we also may reach a situation, at least some of our cities may reach that kind of situation. So with this, let's look at now how to what is meant by sustainable development and what are the goals of sustainable development. So now I think this entire FDP, as I understand, is on sustainable development. I think a lot of people would have talked about what is sustainable development and all those such things. But here we are talking about water, and specifically, say my focus will be on urban water as I proceed further. But as you can see, when you talk about sustainable development, water plays a very, very important role. So what is the foundation of sustainable development? Because it is the most important component, whether we talk about energy development, food, health, peace, and security, and also poverty eradication. So in all these sectors, water plays a very, very important role. So when you refer to sustainable development, obviously water is at its foundation. So water is a very essential element that need to be considered. Okay. What is sustainable development? I don't need to stress on this because the entire course, I think last 3 days you had a number of different presentations. People have defined what is sustainable development. I just borrowed this definition from World Commission on Environmental Development report on our common future. A form of development that meets the needs of the present without compromising the ability of future generations to meet their own needs. That's what we define as sustainable development. And here we are talking about sustainable water management. And this becomes a very, very critical component of sustainable development. And maybe you can define this, again, I borrowed the definition from UN Agenda 21. What is meant by sustainable water management? An adequate supplies of water of good quality are maintained for the entire population of the planet while preserving the hydrological, biological, and chemical functions of the ecosystems, adopting human activities within the capacity limits of nature, and to combat vectors of water-related diseases. It considers various things, and maybe all these things you can see they are related to all these activities that we talk about: energy, food, health, peace, security, and water irrigation. At least you can see food because water is required, and you need to meet the requirements of water requirements for food, and then you need to protect the population from diseases, and mostly waterborne diseases are more prevailing in many of the parts of the world. So health, and then energy, because water plays a very important role in energy production. So thus the sustainable water management plays a very, very important role in the overall sustainable development. But anyway, my focus will not be over general sustainable water management. Today I'll focus on a specific sector under sustainable water management, that is urban areas. So water management in urban areas. Okay, so in fact, I start with what we call as sustainable development goals, which are the goals which were adopted by United Nations member states in 2015 to be, the development goals agenda is for 2030, 2030. These goals are to be met. That's what the target is. So this provides a kind of a blueprint for peace and prosperity for people at the planet now and into the future. That's what these goals state. The objective, the main objective goals is. And there are 17 sustainable development goals. Maybe someone would have covered these things in your other lectures that we have. As I understand, I think you had a talk on sustainable cities in one of the talks, one of the sessions here. Okay. So these are 17 goals that we have. No poverty, zero hunger, good health and well-being, quality education, and so on. What we are interested in, we are looking at is the sixth one, which is related to urban water, clean water and sanitation. This is what is known as goal 6. Out of 17 goals, what we are looking at is the goal 6. So what is this goal 6? The goal 6 is to ensure availability of sustainable management of water and sanitation for all. That's a single statement. Explains what's the main objectives, goal 6. So the sub-objectives are: achieve universal and equitable access to safe and affordable drinking water for all, achieve access to adequate and equitable sanitation and hygiene for all, and end open defecation, paying special attention to the needs of women and girls and those in vulnerable situations, improve water quality by reducing pollution, eliminating dumping, and minimizing release of hazardous chemicals and materials, having the proportion of untreated wastewater substantially increasing recycling, safe reuse globally. And fourth one is substantially increase water use efficiency across all sectors and ensure sustainable withdrawals and supply of fresh waters to address water scarcity and substantially reduce the number of people suffering water scarcity. Implement integrated water resource management at all levels, including through transboundary cooperation as appropriate, and protect and restore water-related ecosystems, including mountains, forests, wetlands, rivers, aquifers, and lakes. So these are 6 goals defined under, 6 objectives defined at goal 6. But the main tagline here is that all these are meant to provide access to the basic needs of the humans, of the society. What are the basic needs? Water, supply, and good sanitation. So this is what is lacking in many urban areas. Okay, same thing happens in rural areas, but I think it's a more challenge to provide this than urban areas because you have a high concentration population. So that's what my focus of today's lecture is today. So I'll be talking about the urban water management in terms with reference to this Sustainable Goal 6. Okay. Now, added to all these things that have been discussing, so there's say water stress because the natural level of water is not uniformly spread, and where you find in countries like India where you have high density of population, the freshwater resources are also dwindling, and so the per capita availability is decreasing, and thus causing more stress of water. And within the country also you have again a disparity between different regions and different say type categories of population. Okay, now to this we have other challenge that we need to face, that is climate change. And the climate change has a very substantial impact on water availability, as indicated by various studies that have taken place over the last few decades. The climate change has a very substantial impact on both water availability as well as water demand. And in fact, whatever we are talking about climate change, global warming or climate change that we have been talking about, I think one of the primary mediums through which it will affect our, population or our ecosystem is through water. Okay, so that's the reason why the water, so what are the major impacts of climate change? One is the climate change is expected to cause changes in precipitation patterns. Okay, uh, this is how this affects the precipitation is not uniform across the world. There are certain regions which are expected to reach more precipitation than what is normal today, and there are certain regions which are expected to less precipitation than what is normal today. But the major issue here is how is this precipitation patterns? Okay, maybe some areas receive more precipitation, some areas receive precipitation because of the impact of climate change. But what is causing a concern for us is that the occurrences of extremes is likely to become more frequent. So there's an increase in the intensity and frequency of hydrologic extremes because of changing precipitation patterns. Find on one extreme, say for example, you take the recent past, if you look at recent years, you've been seeing that many cities are getting affected because of frequent floods. Like Hyderabad, you see every year Hyderabad experiencing high intensity of rainfall and then a frequent flooding in Hyderabad. And same thing in recent, just a few days back, we heard about urban floods in Delhi. Even the airport got flooded. Okay. Now, this is a pattern that you've been observing, and you find that the intensity of this extreme rainfall is increasing and the frequency of this extreme rainfall is increasing. On the other hand, the other end of extreme is droughts. Even the intensity and frequency of this droughts also is increasing. So you find that both of these extremes are happening simultaneously. There's an increase in the intensity and frequency of the hydrologic extremes because of mainly because of the changes in the precipitation patterns. And this obviously will have an impact on the water availability. Okay. Now, a study that we did on the river Godavari maybe a few years back indicated that within Godavari Basin, if you see, take for example the entire Godavari River Basin, the upper Godavari Basin actually has received less rainfall when compared to lower Godavari Basin. And when we look at the future and study the impact of climate change on this, we observe that in fact the water stress in the upper Godavari Basin is going to become more severe. Means there will be less rainfall in those areas which already receive less rainfall, whereas the lower reaches will start receiving more rainfall. So the water availability can change because of climate change. And the other major impact of climate change related to water is an increase in evapotranspiration. Because temperatures are increasing, obviously evaporation as well as transpiration increase. So what is the evapotranspiration? As you know, the evapotranspiration increases means your water requirements of crops also increase. So it's going to be more agriculture demand because of the increase in evapotranspiration. So maybe these four could be said as the major impacts of climate change on hydrology and water resources. So we are already stressed because of the limitation of the freshwater resources, and added to this, we have another challenge to face, that is the impact of climate change. Now, with this all background that I'm talking about, I just generally discussed about the the water availability and the goals of sustainable development, and then the impact of climate change. So with this background, let us move into the main theme of my today's talk, that is the urban water management. Okay. Urbanization become an important aspect. So in fact, across the world, there's a trend that's observed across the world is the urban population is increasing. There's a lot of migration taking place from the rural areas into urban areas, and the personal population who are living in urban areas is started increasing across the world, and more so in our country. Okay, so find what is the impact of this urbanization. So urbanization actually leads to a very accelerated rate of social change because an urban area starts developing so fast that there's a sudden change of, say, a social change in the way the people live. So there's an accelerated rate of social change, and obviously the services that you provide become more and more complex. So there's increased complexity in providing the basic services to the society in terms of water or transportation or health facilities. Any basic needs, if you look at, I think providing them in a city becomes very difficult or becomes more complex. And obviously increased cost of public services and one observation that we have in most of the Indian cities is that the growth is haphazard. Unfortunately, because of lack of proper planning, we find that the cities start growing in a haphazard way, and you find that there's an urban sprawl is haphazard, and you find there's in urban areas there's a lot of social differentiation. You find, very well-developed gated communities, very say with high-income people living there. Very adjacent to that, you find a lot of slums. So this is something which you observe very much in urban areas when compared to rural areas. There's a lot of social differentiation in terms of the income, of the population. And obviously, because of social differentiation, there's also an equitable distribution of the opportunities that are available for them, even in terms of the services that you're providing to them. Okay. So there's, say from the water point of view, okay, you can say, in fact, there's increasing demand for water for various activities. And there's a change in the physical environment altering the water balance. And then disposal of waste that, that are generated from a highly concentrated population can cause a contamination of freshwater bodies. So this, I think, that the direct challenges posed on water sources because of nature. There's more increase in demand, and then the water balance gets altered, and then disposing the waste becomes a major challenge, and that can cause a contamination of freshwater bodies. So these are, I think, in fact, issues that we are going to discuss as I proceed further. So if you look from Indian point of view, in fact, Indian urban population is expected to reach about 600 billion by 2031. This is a study that is conducted by Ministry of Urban Affairs. And if you look at the per capita expenditure needed to provide urban water infrastructure facilities, this is as per the 2012, 2009 to 10 prices. As per those prices, I think in today's prices, this definitely is much more higher than this. Around 13,329 rupees per for capital infrastructure. It means I'm talking in terms of per head. Okay, and rupees 840 per annum for operation maintenance. Per head means I'm talking in terms of per capita expenditure. Okay. Now, if you look at from the point of your total expenditure to make in urban areas for urban infrastructure for requirements, this water sector for providing urban infrastructure, it is 25% of total infrastructure requirement, and the capital cost is around 41% of the total operation maintenance cost that you spend in urban area for all the infrastructure facilities. So you see how much important role water plays in a city or a town. Okay, and in spite of so many developments and so many projects taken up in India, we find even today the quality of water, the service in terms of water provided or wastewater disposal or solid waste disposal, I think quality of services delivered is poor in many of the cities across India. But I think I recall, like I've seen maybe around 30 or 40 years back, I think we were depending more on municipal water. We never bothered to buy water unless we are traveling and then we don't have safe water. We used to directly depend upon the municipal water for our daily requirements. I think today, very few of us have, say, I think, directly use that, say, in fact, the municipal supply given to our houses. I think there's a lack of confidence in the, say, the quality of waters provided by the, say, municipal corporations or municipalities, and so people started depending more on the private sector for getting the better service of water, and that's what is happening across many cities. And no city has 24/7 water supply. I think this is something which is the government of India is taking up, trying to take up, and I think few cities it's being experimented, but still I think nowhere it's completely implemented with 24/7 water supply. And collection and treatment of wastewater is either not present in many of the cities, or even if it's present, it's not effective. Okay, and then most of this wastewater or the solid waste generated from the cities is being disposed in openly, and so it's causing pollution of rivers as well as groundwater. And in terms of the access of urban water services, I think there's no equity. Still, I think there are many, a large section of the population who do not have access to, okay, if not for drinking water, at least access to the sanitation facilities. And as I just now mentioning, flooding has become a major issue in most of the cities because of the inadequate stormwater management systems. Okay. Now, to prove these things, I just take a case study of an example that which we studied, a city of Hyderabad. Okay. Now, when you look at the city, how the city Hyderabad has grown over the last few decades, these are the land use maps that we generated based on the satellite maps that we got from 1972 to 2013. Okay. So this is the city. The red shaded area indicates the built-up area. This is how Hyderabad was in 1972, and this is what Hyderabad is in 2013. Please note, already 8 years has passed this, because this is based on a study that we conducted in 2015. I am able to show this only up to say 2013 here. Okay, maybe it has further grown beyond this point in the last 8 years. So to find how the city has grown here, and this is almost a rapid growth, almost an exponential growth. You see, especially from 1990s, the city has grown exponentially. Means I'm talking about the built-up area. Built-up area is this red area. Means highly built-up area is shaded here, right? So you can see how the city has grown over this. So what's the impact of this growth? Now you have the population. Obviously, the built-up area has increased, means the population has increased. So you need to provide water for this population. Okay. And also other sectors. So if I look only from water supply, demand, and water supplies and demand, this is what is being this is the demand, how the demand has been growing. You can see as the population has increased, demand also increased steeply over the last, from 1990 onwards. It's an exponential growth of the demand. This line shows the demand, and these other lines, they indicate what is being supplied, okay, to the city. So maybe till around 1970s or 1980s, in fact, the two reservoirs that were constructed by Sir Visvesvaraya in say in early 20th century, the Usman Sagar and Himayat Sagar, were able to meet the requirements of city most or less up to 1980s, mid of 1980s. Maybe slightly, say from 1960 onwards, the demand was slightly higher than this, but more or less, these two reservoirs were able to meet the requirements of the city. But from 1990, you can see that, say, the city is growing exponentially, so you have to start looking for other sources. Okay, groundwater, and then I think later Singur Reservoir was constructed. The data, say, water was taken from Manjira project, and then now there's proposal. I think already started. There's a proposal to draw water from Krishna River, and now there's another proposal to draw water from Godavari. So, what is happening is, because of the increase in the say population and the growth of the city, the water demands obviously increase accordingly, and the available water at that location are not able to meet the requirements. So what you started doing is you started importing water from outside. So large amount of water has to be imported from other side. So can we allow the growth to take place like this? This is projected up to 2030. We are already at 2020. So can we allow this kind of growth of the demand and the supply? So obviously, if you start allowing this kind of growth, it becomes unsustainable. How can we meet this kind of demand, increasing demand? So I think we need to do something to make it more sustainable. Okay. Another issue of this rapid urbanization that's happening, like the city of Hyderabad. I just took an example of Hyderabad because that's what we studied. But the same thing is happening across many of the major cities, metro cities like maybe Bangalore, Chennai, and Delhi, and other cities. So this rapid increase in the population and then urbanization will have another impact on the precipitation pattern in the cities. This causes a phenomenon called urban heat island. So this is an urban area, and this urban area obviously is like a concrete jungle, and it traps the heat. And what happens? This area obviously becomes traps the heat, and so this has higher temperature and compared to surrounding areas. This is what you call as heat island, and this heat island can cause a change in the precipitation patterns. And thus can, in fact, alter the precipitation or increase the intensity of precipitation, especially on the downward side. Okay. Now we try to study this in Hyderabad in one of our studies. We took aggregated rainfall data from that is available from MIT. So Hyderabad, actually center of Hyderabad is somewhere here 6, and then Hyderabad is going in this direction like this. So we divide all these grids into urban and the non-urban areas, and we try to plot the rainfall, total monthly rainfall at these locations for both urban grids and then the non-urban grids. And we divide total duration of rainfall data that we have into 2 parts, 1971 to 1988 and 1989 to 2007. What we observe here is that, okay, even 1971 to 88 also, during the monsoon season, the rainfall in the occurring in the urban areas was more than what is happening in the rural areas. But if you observe recent past, 1989 to 2007, you find the rural areas, there's not much change, the rainfall pattern. But the urban rainfall has obviously increased. Okay, because I'm talking in terms of average rainfall, average rainfall increasing from something like 170 to around 200 millimeters in a given month, obviously it's quite a significant increase. Okay, so this is what has been happening here. So there's a change. And other study that we try to do here is we try to look at what we call as extreme rainfall indices. Okay. Which indicate the occurrence of extreme rainfall. So, for example, SDD11, it's the ratio of annual precipitation to the number of wet days. So, this indicates, for example, annual precipitation by number of wet days. If the number of wet days is increasing or the annual precipitation increasing, obviously this will increase. That means this is an indication that there could be more rainfall occurring less number of days. So, we find there's an increasing trend based on the data that we have plotted between 1971 to 2013. Number of days in a year when the rainfall is more than 20 millimeters, even that you find there's an increasing trend. And then the annual rainfall from days where the rainfall was more than 99 percentile rainfall, daily rainfall also has been increasing. And the number of consecutive wet days, you find that's decreasing. So this, in fact, our study indicates that the total annual rainfall that's occurring in the Hyderabad city has not changed significantly, but the number of wet days has decreased, and that means what it indicates is that there's the same amount of rainfall is occurring in less number of days, and thus there's more intensity of rainfall, extreme rainfall, and this is the result of what you've observed in Hyderabad today. Many of this this has become very frequent in the recent past. Last year October, there had been a very severe rainfall, and a lot of areas in Hyderabad got flooded. And in fact, though these pictures were taken from 2008, you find a similar kind of situation almost every year in Hyderabad. In fact, just 15 days back also there was a similar kind of rainfall in Hyderabad. So even a normal monsoon season also you find that this kind of flooding has become very common in the city of Hyderabad. And I'm not, though these pictures I'm showing with reference to Hyderabad, I think this is a situation in most of cities in India. It's not just confined to Hyderabad. Okay, forget about cities like Chennai or Mumbai, which are coastal cities, and then they have been facing problems of because coastal areas and coastal cities are different. But I'm talking about cities like Bangalore, Hyderabad, Delhi, which are which never heard about floods about maybe 30 years back. Now they are experiencing this kind of situation almost every year. And one of the reasons is this rapid urbanization and then the increase in the extreme rain, high intensity rainfall events. Okay. So let us now look at how do we tackle these issues that I've talked about. Say a rapid urbanization causes more flooding in the cities because the stormwater management becomes more a big issue. At the same time, there is increasing demand for water, and so you're trying to import water from other say basins, and this can become unsustainable. So how do you sustain this situation? How do you tackle the situation? That's what maybe my main focus will be when I talk about sustainable urban water management. Please feel free to, if anyone has any doubts in between, you can always stop me or maybe you can put it, say a question here. I hope I am audible to everyone. Okay. Yeah. So if I consider say components or different components of urban, what we call as urban water. If you look at the urban, a typical urban water infrastructure system, you'll have to identify a source, you have a supply, you draw water from there, you'll have a treatment system, treatment plant and distribution system, and then supply water to maybe the houses as well as industries and other commercial organizations. Okay. Now, most part of this water that you're supplying, as you know, all know, almost like 80 to 85% of this water that you're supplying comes out of the wastewater. And so you need to have some kind of system to collect this wastewater and then transport it. And then maybe you need to have some kind of treatment system before you dispose into the natural water bodies. Or maybe you can think of reusing this wastewater. Same time, these urban areas will experience rainfall. And so you need to have, because you have altered the natural drainage system in the city by your construction activity, you need to have a drainage system which will collect the stormwater and dispose it off without causing a problem to the city or town. Okay, so thus in a typical urban water infrastructure system, we have three major components: water supply, where you're concerned about both quantity of water that you're supplying and the quality of water that you're supplying, storm water, and then the wastewater. But I have included even solid waste also here as one of the components of urban water, because though it's not water, but the solid waste has an impact on the urban water systems, because say like dumping of solid waste in the urban areas can cause pollution to both the groundwater as well as say the storm water that flows over the surface of the urban areas can actually interact with solid waste and thus cause pollution to the natural water bodies. So when I talk about urban water, I think we need to integrate or consider along with the solid waste disposal system also. Okay. Now, if you look at the urban water cycle, so for example, if you take this is a typical natural catchment that you have, which has some vegetation, greenery, and then there's some precipitation occurring in this natural catchment, and part of this precipitation goes back as evapotranspiration, and then you have runoff and infiltration. So in a say typical, if you look at a natural watershed, usually you find that a major part of the precipitation goes either in form of evapotranspiration or in the form of infiltration, and these areas produce less runoff. But what we are trying to do through urbanization is completely alter this natural water balance. So look at typical urban water balance, or what I can as a urban water as a cycle. Okay, there's a frustration here. And to meet the demands, I just now showing an example of Hyderabad city. Uh, this water available naturally here is not sufficient to meet the requirements of the urban area. So what you are trying to do now here, you are trying to import water from distant areas. So you are importing large amount of water from other areas, other basins. So you have the natural precipitation, but because that's not sufficient, you are trying to draw a large amount of water. And a major part of this water that you are importing from other areas comes out as waste discharge, and you need to think of disposing this. And because of the say the entire say through process of urbanization, you're in fact making all the surface impermeable. There's obviously reduced infiltration, and there's less vegetation in urban areas. Those reduce evapotranspiration, and thus most part of the rainfall that occurs here starts flowing down as runoff, and because this runoff starts going over the surfaces, land surfaces, or the paved surfaces, and may interact with the waste that is disposed at different points. This quality of the runoff obviously also is getting affected. The quality of water runoff here is not polluted, but obviously this quality here is poor. Okay. So all these yellow arrows that I have indicated here, they're all the altered state. So we are completely changing the balance of water balance in upper area and completely altering the entire hydrology cycle in the upper area. So we are dealing with an increased wastewater discharge, a large amount of water has to be imported from other areas, and then you are having a large amount of runoff also which has to be disposed. So deal with these three major components. So before I go into the concept of how we manage these three components, let's look at the interaction between the three water components. Most of the time we neglect this interaction. Okay. In an urban area, you're providing water supply. Okay, and okay, the water supply could be provided from say various sources. You have different sources, but maybe in fact, certain sources could be would have a positive impact. Like if you can recycle the wastewater, maybe or say you can actually try to reduce the amount of water that you're importing from outside. So that can have say a positive impact. But otherwise, you are trying to draw water from various other sources. So there's a link between obviously water supply and wastewater, because most of the water that you are supplying comes out as a wastewater. And then other side you have storm water. So you can try to make the storm water, in fact, make use of the storm water, and that's where you can obviously have a positive impact of the excess storm water generated. But that's not what's happening here. Most of the time, what is happening here is we're not harvesting this water, we're not making use of this water, we're always trying to looking at how to dispose of this water. At the same time, because of the computation of the entire surface, there's reduced aquifer recharge. At the same time, we are trying to draw a large amount of water, groundwater, and so the groundwater levels get depleted. So there's a kind of cycle of interaction between the different components. So this is, I think, which we need to understand before we actually proceed further and see how to manage these three components of urban water. And this urban water is not isolated. It is linked with all other sectors of urban sectors like land use planning. Say in fact, any change in the land use pattern obviously will cause a change in the local hydrology. And say in fact, the land use planning is affected by the water availability and also the flood risk at this location. And housing, transport, parks and recreation, economic development, urban agriculture, energy, waste, health, all these sectors are linked with water cycle. So thus, managing this water, urban water, and three components of urban water, through that we can also, in fact, reduce the negative impacts of the urbanization on other sectors also. Example, to control the stormwater, maybe reducing the say flooding of the properties. Uh, so by controlling the wastewater and the pollution caused by this wastewater, you'll be able to control, improve the health conditions. Or maybe, say, by controlling wastewater or the stormwater, you'll be able to manage the storm, say, solid waste much more effectively. And in fact, some of this wastewater as well as the solid waste could be a source of energy in urban areas. And sometimes this wastewater and the stormwater could be used for, say, as a source for urban agriculture, where maybe you can increase the productivity in urban farms, what we call as urban farms. And maybe if you can manage this, control this demand, water demand, you'll be able to say, in fact, the water scarcity can restrict economic productivity. So if you can provide good water supply, you'll be able to achieve a better economic development and say better water say management system in urban area can actually improve the recreation facilities within urban area. And also, obviously, this have an impact on the transport systems because frequent flooding can cause disruption to the transport systems and thus damage to the urban infrastructures because of floods and other extremes. Okay. So, what are the objectives of your urban water? As I mentioned earlier, say one of the major objectives of urban water management is to ensure access to water and sanitation infrastructure and services to everyone in the city, living in the city. So these are the two basic requirements of any citizen residing in a city. So you have to ensure that there's a proper access to water as well as sanitation and services to every individual in the city, and manage stormwater, wastewater, stormwater drainage and runoff pollution, control waterborne disease and epidemics, mitigate floods and droughts, and prevent resource degradation. So I can say these are the major objectives of urban water management. Now, if you look at the way we are, say, practicing the urban water management in our cities in India, now we are considering the water supply, sanitation, wastewater treatment, stormwater management, and solid waste management. These are the 5 major components. So, but we have never tried to understand the linkage between these services, and most of cities you find that these are all considered isolated services. See, in fact, you have a separate department for supply, maybe a separate department for sanitation, wastewater treatment, and maybe a completely different, maybe sometimes, okay, wastewater and stormwater may be combined together, and a completely different department for managing the solid waste. So there's no interaction of this. We never consider them as, together. We usually consider them as their services, which is not correct. And that's how we are neglecting the relation interdependence between the components, and obviously once you're not considering the dependence between these components, also dependence of these components with other components of urban infrastructure. Okay, and another major say problem with the way we look at the urban water today in most of cities is we never try to distinguish between the quality requirements of different uses of water. For example, you are supplying water for a house. Now, obviously, say your quality requirements for say for drinking water are highly stringent, and you need to maintain those standards. But for example, you need water for washing your house or washing your vehicles, or maybe gardening, or maybe parks and say other recreation facilities. You need water for maintaining those infrastructure facilities. So I think the quality requirements are not as stringent as what you require for drinking water. But unfortunately, when you talk of supplying water for various activities within a city, we never distinguish between the different uses and the different quality requirements. All water requirements need not be provided with the same quality. So that way, maybe say we are actually wasting a lot of our resources where we are treating or say we are spending huge amount of money to treat the water, and that water when it's being supplied to a place, you are just using this water again, just say maybe to water your say provide water for the gardening area, or maybe wash your say car, or for something which maybe you could have used a different source of water for that. So this is say the way of supplying water. I think we are not able to distinguish between the different quality requirements for different uses. Okay, so uh, obviously the way we are managing water today in urban areas, the way we managing water in urban areas today is obviously not sustainable, and it's where we are trying to look for a different way of managing this urban water. Okay, so what we require is a kind of integrated approach for management of urban water. And this is something which is realized across the world. It's not, I'm not just talking about India. I think the same thing is applicable to different countries. And I think many of the, say, developed countries have, say, understood the implications of this present way of managing the urban water. And we are moving towards what we call as sustainable urban water management. The different initiatives taken by different organizations across the world. For example, in the European Union, there is a research program called SWITCH, which talks about integrated urban water management. So this and many of the cities in the European Union, they're slowly moving towards this program and trying to implement this integrated urban water management. In Australia, okay, what we are calling as, what I am calling today as sustainable urban water management, in Australia it's called water sensitive urban design, and in USA it's called low impact development. What was the name which you call them? LID, or water sensitive urban design, or IUWM, integrated urban water management. The basic idea is, say, you have to understand the linkages between the different components of urban water and the linkage of these components with the other sectors of say an urban area, and then develop an integrated management approach. Okay. So all these initiatives that are taken try to move towards that goal, and they're trying to develop different initiatives to attain sustainability as far as water management urban areas is concerned. Okay. So, in fact, this concept of sustainable urban water management, in fact, what I was talking about, the SWITCH program in Europe, they define a concept of what we call a sustainable city. Okay, I think this is something which sustainable city. Okay, it's a general thing. I think one of the talks that you had in this course, I think, was on sustainable cities. I think yesterday afternoon you had by Professor Dr. Sudhakar. So the sustainable city is say maybe the sustainable water management that I'm going to talk about is one of the very essential requirement to make a city sustainable. So a sustainable city is one which actually enhances the quality of life and social well-being. With this part, I think most of this part would have been covered by Professor Sudhakar in today's talk. But what I'm going to focus is one of the components, important components of sustainable city, that is what you call a sustainable urban water management. Okay. The question that arises is, when can we say our urban water systems are sustainable? And what kind of changes do we need to make the way we manage the urban water today to make it more sustainable? So these are two questions that I'll try to answer in the remaining part of my lecture. Okay, how do we make them sustainable? How do we make the urban water systems more sustainable? And what kind of changes are we going to make in the way we manage the systems? Okay. As I was talking about, the different initiatives taken across the world to make our cities more sustainable in terms of water management. And in that process, in fact, I just found this, there's an interesting article published in 2009, which talks about the transition states of a city, how a city undergoes changes as it develops. Okay. Now, if you try to look at historically how the cities were developed, maybe in initial days when the, say, urbanization started, I think people focused more on providing water supply to the city. So maybe the initial stage was what is known as water supply city, where the focus, say, of the engineers were only to provide water supply access, okay, and security in terms of the quality required. So, if you look at, say, in fact, even historically, even say in India, old cities, people those days you were looking at only the water supply, how to treat the water and to required quality, and then supply to all the households. So we were looking only from supply hydraulics, like how to design a water distribution network, how to design a water supply, water treatment systems, and so on. But as the city started growing, people started feeling that there's need for providing, say, protection against pollution. Okay, so this the concern of public health has become important, and this way, say, we started going for because people realize that there's going to be obviously more wastewater generated, and there must be some way to say, in fact, dispose this waste. Otherwise, it will cause a problem to the public health. And so we started talking in terms of wastewater disposal, and that's how the city evolved into what is known as sewer city. Okay, where you, in addition to water supply, we started providing sewerage systems like drainage systems to dispose of the wastewater. Okay, then as the city started growing, people started realizing that okay, we have altered the say the local this thing, and so we say topography, and so dispose of rainwater becomes a problem. So we say the city started facing the problem of floods, and so then evolved the concept of designing drainage systems to dispose the excess storm water, and that's how the city has become a drained city. The next stage was drained city. So where the aim was to provide flood protection, so then providing drainages, open say channels, drainage channels, and then disposing this storm water has become important, and that's how these things, these engineering concepts are evolving. Okay, I think as far as India is concerned, I think most of cities come under one of these categories. But most of second or third, say, in fact, I can say the small cities, in fact, mostly are confined towards this. Okay, because if you look at those small towns and cities spread across the country, many of the cities do not have a proper, say, wastewater say collection and disposal system. Now they have a proper drainage, a stormwater drainage system. So at the most, what they have is a water supply system. So they have maybe most of the municipalities or this local government will concentrate mostly on providing safe safe drinking water for the population. So they confine themselves to only water supply system. Okay, I think many of the major cities, towns and cities have at least some, say, the wastewater disposal system, and to some extent the stormwater disposal system. So maybe I think in India we stopped at this point. We didn't evolve beyond this point. Okay. Now, over the years, what happens now? You need to look at the social amenity and environmental protection, and so that's where the concern of say pollution for both point sources as diffuse pollution. What I mean by point sources is okay, because there are a lot of industries coming up, and these industries have to dispose their waste, and this waste, if it's disposed river, is caused point source pollution, and then maybe there's a lot of pollution caused because of diffusion through the runoff, because runoff flows over the say surfaces and carries along with it the pollutants because of the improper solid waste disposal. So then how to manage this pollution, both point and non-point source pollution, has become a concern. Okay. Once we evolved from this, people started realizing that there's limitation on natural resources. Okay, there are enough natural resources, but these natural resources are not sufficient for meeting the requirements, growing requirements of the demand locations. So we started thinking of, say, conservation and providing, say, protection to waterways and all such things. And so it has become into what is known as water cycle city. What is aimed at through this concept of sustainable urban water management or integrated urban water management or low impact development, whatever is the name with which people are calling across the world, we would like to make our cities as water sensitive city, where you have intergenerational equity, resilience to climate change, and so we need to be adaptive, multifunctional. We need to provide multifunctional infrastructure and urban design, reinforcing water sensitive behaviors. So this is what I think we need to evolve. I think this is what all these initiatives are taken in different countries are aiming at. Okay, they may not be calling these names. This is what I borrowed from Australian concept. This is actually based on this publication is from Australia, so this is an Australian concept. But I think this is the aim of all any say town planner or city planner would like to make cities to become more water sensitive. So I think we have to go a long way before we reach this point in India, because I think in India we stopped at this point. So we still are yet to go towards this, and that's what I think we need a lot of changes to be made in the way we look at the uh, urban water to make our cities more of water sensitive. Okay, how do we achieve all these things? Okay, it's a water sensitive city. Yes, we'd like to say improve the say uh, provide the required water facilities. At the same time, we should make it more sustainable. Okay. Now, I discussed earlier the changes that are happening in urban water balance. So this is what's happened because of urban growth. Now we would like to alter this so that it becomes more sustainable. So how do we achieve this? So we can make a city a water sensitive city by altering this water balance, urban water balance. How do we do this? Okay. Now we try to say control the demand, manage demand, so that you reduce the amount of imported potable water. This is the imported potable water. If you can reduce this imported water, how do we do this? One is by control of demand. I'll discuss that a little while later. So we can control. And through reuse of both the storm water as well as the wastewater. So you reuse the storm water, you can reuse the wastewater. So thus you are trying to recycle the water. So the need for importing water from outside gets reduced. So we'd like to reduce this, because this is one thing which is making our cities very, very unsustainable. So if I can try to control this, the wastewater, say by recycling wastewater as well as the storm water, that's one way in which you can reduce the amount of water being imported. Okay, we'd like to increase the infiltration as well as the evapotranspiration, so that there's less runoff produced because of say rainfall. So how do we do this? Try to go for more vegetation in open lands and other things, so that there's more evapotranspiration. And maybe through different activities, like for example, in fact, I've been discussing different type of systems that we can adopt in urban areas, which can increase the infiltration rates, and thus more water can go down through infiltration, and there'll be less for stormwater generated. Okay. And then, okay, we can also recycle the stormwater by, say, having some kind of treatment. And to this process of treatment, a part of stormwater also, in the process of treatment, can also get infiltrated, and thus the amount of runoff that's produced from the urban area gets reduced. Okay, so if we can do this activities, one is recycling of stormwater, treatment and recycling of stormwater, reuse of wastewater, and increasing the infiltration evapotranspiration, say in the city, and reduce the amount of water being imported from outside the city, we can make a city more water sensitive. This is what is defined as water sensitive urban design water balance. So we would like to, now this is what happened in urban areas. This is urban water balance as on today. So we'd like to alter this. We altered from the natural water balance to this category, this phase. From here, now we would like to alter and make it to this, so that it is more or less similar to the natural water balance. And thus, the say the city or the say area becomes more water sensitive. So this concept of urban water management obviously considers all parts of water cycle. Say, in fact, the earlier approach of urban water management is we consider water supply is different from the wastewater disposal and the stormwater disposal. So when you focus only on water supply, obviously because you are not able to meet demand, you start importing water from other places. Okay, and then you are concerned about how to dispose of this wastewater generated from the urban areas, and then the urbanization increases runoff, and then you are concerned about how to dispose this waste the water. So if you can look at all these components as integrated in an integrated approach, maybe I can classify the water into different categories like blue water, green water, gray, black, and brown water. Say I think these are terms that you have been hearing about. So maybe they're all water. So you have, say, rainwater, blue water, and then green water, gray and black water, or brown water. They are all the wastewaters. They are different with different qualities. And then reclaimed water, virtual water is what actually is coming in terms, not directly in terms of water, but maybe, for example, you are importing food grains, you are importing vegetables, you are importing fruits and other things which are being consumed in the urban area. So all this can be considered as what you call as urban virtue water. So we can consider all this water, various types of waters as one integrated, as same, in fact, as part of the water cycle, and consider them as integrated. I think that will give a different way of approach for us to look at the water from a different angle of looking at water in urban areas. Okay, so now you have each word has its own quality of water. So if you can try to match the quality of different sources with the quality of required for different uses. As I mentioned earlier, all requirements do not need water with the same quality. So if you can try to match the quality of different sources and the quality required for different uses, I think we need not have to bother about importing water and treating it at high cost and supplying for water. So you focus only on the domestic consumption. You need a different quality of water. For say maybe a commercial, say industrial use, you require a different kind of water. For maybe in urban, say farming, agriculture, like for example, maintaining parks or other greenery in the urban areas, you require a different type of quality of water. So 95 different, say that if you can understand that different uses require different quality of water, I think you can look at those quality of water from different sources of water that we have, different types of water that we have from in the urban water cycle. And so instead of thinking always in terms of disposing the wastewater, disposing the water that we have, I think we need to start thinking in terms of storage, treatment, and recycling of the various wastewater generated from these areas. Okay, so integrated urban water management, that's what it consists. We have these are 4R integrated. There's an overlap: urban drainage and flood management, sanitation, water supply, solid waste. They all are integrated. They're connected to each other. So what we need to do, in fact, we are looking at this part: integration of land and water management, and say the final aim is to improve the quality of life. But what we require is, okay, one is a strong willpower, political willpower or legislation to achieve this kind of integration of various urban sectors. And from as engineers, from our side, I think we need to look at what kind of say changes we need to make in the design of the infrastructure facilities that you're providing in urban areas, so that we'll be able to better manage these facilities. Okay, so I'll start talking about each of these components of urban water and what kind of changes we need to make in order to make these sectors more sustainable. Okay, so one side we have, so first thing that we talk about is demand. So we need to, I think, optimize the supply and manage the demand. And obviously, this is something which is, I think everyone has to accept that we have to provide equitable access, and obviously for doing all these things, you need to have an improved policy and intersectoral approach. Now, as far as the stormwater is concerned, stormwater is, in fact, we can look at stormwater as a source and not as a nuisance. So if we can show stormwater as a source, then we try to attenuate the peaks, try to make use of the stormwater that cause in fact, reduction of the peaks of the floods and also reduce, urban flooding. At the same time, you are providing some kind of, you are providing some other source of water for various activities. And the same thing can be looked at from the wastewater also. Wastewater can be separated source and used. And so instead of looking from increasing of supply from other areas, I think we need to look at how to reduce the water demand. So we need to look at different kind of innovative solutions so that the demand for water is reduced. And for this, I think it is need for a physical institution integration of management. So how do we make it more sustainable? We have to look at the reassessment demand forecast, try to look at alternate source of water. And most of the urban areas, water supply systems have a lot of leakages. And so if you can reduce the leakage, control the leakage and wastage water, I think that we can reduce the demand or control the demand and also try to reuse the water as I was saying. Now, I'm just again reproducing the same graph that I showed earlier. What's happening in the city of Hyderabad? Okay, this is typical. I'm just showing this for Hyderabad, but this is typical for any city. If you take any city in India, I think this is what's happening. There's a steep increase in the demand because of the rapid urbanization. And to meet the requirements of water, what we are trying to do today is we are trying to import water from different locations. So we start looking at other sources and maybe you start importing water of long distances. And so what's happening in Hyderabad? Say, in fact, Singur and Manjira are close to Hyderabad, but now from Krishna water and Godavari water, you are drawing water from hundreds of kilometers to bring to supply water for city of Hyderabad. So this obviously is becoming unsustainable. So how do we manage this? How do we make it sustainable? What we would like to see is at this kind of pattern. Okay. So this is, I say, this is how projected water, in fact, how the demand pattern should change, demand forecast should change. These are the available resources. Okay, available resources say need not be remaining constant. Maybe you start importing some water from outside. So you have an increase in population, so demand is increasing. But as the population increases and there's more economic development, because more economic development obviously will create more industries and more commercialization, and so obviously per capita consumption increases. So because of that, there's an increase in the demand. So this is something which is always happens in any as the city starts growing. As the city starts growing, there's an increase in population, so there's more water required, and there's an economic development, so you need more water because of, say, for various economic activities, and then the per capita consumption also increases because if you try to compare the standard of living or in a rural area with the standard of living in urban area, obviously upper area standard of living is much more high, say different, and so the per capita consumption obviously depends on standard of living, so there's more consumption of water. Okay. Now, as this you increase water supply, you can, in fact, start with the first thing that we can try to do is try to introduce leakage control. So, by control, because if you look at any city or town in India, if you ask to walk to say along the water supply networks, you find there are many locations where there's a lot of water leaking, either it starts flowing over the roads or into the drains, or maybe you find this kind of leakages are very common in most of Indian cities because you are laying large number of pipelines and obviously there's a lot of leakage. So if you can try to control these leakages, then maybe because as indicated by some studies, I think there's almost 20-30% of the water that actually is being treated and supplied is going down as wastage because of leakage. So try to introduce a leakage control program, so that can reduce the amount of sediment could be controlled partly by this, and then we can start reusing the treated effluent for industrial demand. So you have wastewater. If you can try to make reuse of this wastewater and then start using this for maybe to meet the different industrial demands. But certain industries may not require high quality of water, so maybe recycled water could be used for industry demand. And then actually, I think we need to look at our designs of water, our say water faucets in our homes, apartments, and try to make them more water efficient. For example, the flushes that we use in our washrooms, or the taps that we use in bathrooms and kitchens. I think if we can make them more water efficient, I think that's another way in which I think can make them water efficient and reduce the losses that we have in the water sewage systems within an apartment or a house. And then over the years, we can try to go for rainwater harvesting and recycling of the stormwater. And this how we should target that instead of this demand curve continuously increasing, as time proceeds, this actually has to start falling down. This is how the demand has to change over the years. Instead of the way I have shown here, the demand is continuously increasing. If we can try to take this kind of measures in a city or town, we can actually try to reduce the demand. So, and then say this obviously demand that you have demand for water is within the limits of the water availability that you have. You don't need to import water. Whatever water you have within the city should be able to sustain the requirements or should be able to meet the requirements. So this is, I think, these are the things that we need to do as far as the water demand is concerned. So we have to look at the water leakages and ensure that the supply efficiency increases by controlling leakages, and try to look at the treatment or recycling of wastewater as well as rainwater. At the same time, I think we need to look at say new engineering designs which can make our water faucets and water distribution systems within an apartment or within a house more efficient so that the losses get reduced. Okay, so this is how we can try to say control demand. Now coming to stormwater. So as on today, what's our approach? I would like to say when rain occurs, say as an individual house, I have an apartment or a house, and I don't want to see this rainwater accumulating in my house. I would like to dispose it as early as possible. So when I construct a house, build a house, I'll try to see that whenever rain occurs, I'll try to push out the rainwater out of my house. That's what everyone is trying to do. And that's what the city is also trying to do. In the process, we're always looking this as a nuisance, and we're always looking from the point of view disposing this as early as possible. And in the process, what happens when you have a more rainfall, intense rainfall, the sudden say increase in the flow, and that's what is causing flooding. In fact, flooding, urban flooding, when compared to river floods, it's actually very, very in fact, it's caused because due to very small rainfall. It's just 15 minutes or 20 minutes spell of rainfall, you see many of the urban areas get flooded. So, and at the same time, because you're not allowing the water to remain at the location where it occurred, there's less opportunity for the rainwater to infiltrate and recharge the groundwater, so there's increased groundwater. And because the velocities are higher, it's also causing erosion and sedimentation and also pollution of the river water. So this is say this approach that we are adopting for controlling the stormwater in urban areas, I think itself is completely unsustainable. So looking at the stormwater as a nuisance, I think is wrong. If you can look at stormwater as a source, okay, stormwater is not a nuisance, it is a resource. So how you control this at the source itself. So one is, for example, in most of major cities, today, in fact, less of individual houses, in fact, more of communities living together, maybe in terms of apartments, a large gated community apartments or a large community of gated communities with individual houses. So I think it's more easy for them to actually plan their community in such a way that they control the water within their source, so that it, the stress on the main drains gets reduced. So we have to look at the point of view, control the source. So let every individual house, every individual apartment make their own alternate measures to say either infiltrate the say stormwater coming into them, they retain it, and then through infiltration or storage. I think some say efforts have been made in this regards, and then in fact some of the cities like I think in Hyderabad, even in Warangal, or in I think Vijayawada, in some cities the government said every house should have their own infiltration ditches, infiltration trenches, so collect the rainwater into infiltration trenches, so the infiltration takes place. But I think that's not the only solution, because infiltration trenches will not work in every location. So you need to look at alternate ways in which the stormwater is retained in the at the source itself, so that there's retention of the peak on in the main say stormwater drainage systems that you have. And okay, you're collecting the stormwater. The stormwater has its own. It's not. It has got its own quality limits, and maybe before you can use the stormwater as a source, you need to have some treatment. Again, collecting all the stormwater, having a treatment system, a centralized treatment system is going to be very, very expensive. So what you need to encourage is to go for some kind of decentralized treatment. As I said already, in most of the major cities, you have communities. It's not individual houses. There are a group of communities living together. So in the community, if the group of people can come together, and then whatever stormwater is collected in their premises, if you could collect it, stored, and then they can have a simple because when you do not allow the stormwater to flow over the surface and collect into the stormwater drainage systems across city, I think the level of pollution of stormwater gets reduced. At the most, what you can have is some amount of diffuse pollution coming from your rooftop or from the garden areas as it flows into your say infiltration or collection systems. So we can have some kind of a simple treatment system, a low-cost treatment system, to a decentralized treatment system. And this stormwater can be used for improving, enhancing landscape, and provide more recreation facilities using this stormwater infrastructure. Okay, and thus by harvesting the stormwater, and this water that you are harvesting, water that you are storing, can be used also for certain activities, and thus supplement the water supply. And that's how you can reduce the amount of water supply that you need to get for a community. The different ways, in fact, if you look at literature, you find a lot of different ways in which you can actually control the stormwater. And most of the time, these facilities also improve the landscape. Say, in fact, they bring beauty to the area. I don't know, for example, some of you would have seen, say, some of the new airports or some of the new premises being constructed at different locations. Like, example, I'll just give an example of say, the airport, Hyderabad airport. I don't know how many of you have seen the Hyderabad airport. It's supposed to be a greenfield airport. To see the premises of Hyderabad airport, you find this kind of many of this kind of structures, and you find it as, in fact, it's a very beautiful landscape. And most of the stormwater collected there actually gets collected there, and then it disposed there itself. So you'll have this kind of say drains instead of concrete drains. It's called swales with grass cover. So it also enhances the landscape. At the same time, when the rainwater flows over this, there's more opportunity for it to infiltrate. That's how this is called swales. And then maybe you can have what you call as bioswales, where you have some kind of plantations which can use the stormwater. It's called bioswale. So some kind of treatment also takes place here, and maybe you can have if land is available. So because urban areas, land is very precious, and not everywhere land is available. So we can have land is available. We can go for what we call as just some kind of detention ponds, which can collect the rainwater, stormwater, and then retain it. And this could become a kind of a recreation spot. And a new say technology is coming up. These what we call porous pavements, which are not completely impermeable. So when the rainwater flows over this, they absorb the rainwater and then cause more infiltration. We have this kind of infiltration systems can develop in small localities where some land is available. You can just create a landscape like this, and this will collect the rainwater, or you try to divert all rainwater here, and it can collect and then can be do this. Can actually not only help with landscaping but also in infiltration. And maybe you can have some kind of roof water harvest system which will collect the rainwater from the roofs, and then we can have either a kind of swan storage systems like in form of a sump which you collect the water, and maybe you can have some treatment to recycle this water and use it for your activities, some kind of uses in the within the house. Or maybe this treated water can be put into a kind of a recharging system, a well or something open well, where it can cause recharge of water. Okay, this another concept is coming up in the recent past is green roofs. Maybe it's not always possible. They're costly, but it's expensive, but still is something which can maybe certain communities can adopt what we call as green roofs because they absorb whatever rainfall is occurring on the roof itself. So I just try to show by pictures the different, say this is something we always can look at this and then based on location, say they're all something I borrowed from different sources, all these pictures and all those things. But please note that this all something more creative. So if you have an inclination towards say this thing, I always think, and I think we can try to actually think innovatively and develop our own ways of say controlling the stormwater by say looking at this kind of things. Maybe the local, based on local community, local say land use pattern, all those things. We can have our own systems. And I think there's something which has been practiced earlier in India. In some, if you look at the ancient literature of old cities, I think in India, I think you may find some kind of such kind of say ingenious techniques through which people used to harvest water, clean water. Okay, so for example, this can be used for landscaping our communities by these various systems that you can collect the control the stormwater. Okay. Coming to wastewater, I think this is another important component of this. We have a large high water use, and then most of the time what's happening is, in fact, even in terms of water use also, you have different types of activities, and different activities produce different quality of wastewater. But unfortunately, what we do is our conventional system is we try to mix all these waters. Okay, the water coming out of say maybe your toilet, water coming out from bathrooms, kitchen, all these waters are fixed. Everything is considered as wastewater and all these are fixed. So you have certain say types of water, the quality of water is very, very bad. And certain quality, I think, is more easy to treat. So unfortunately, what's happening is because we are mixing all these things, the amount of wastewater generated is quite large. And treating that kind of large quality of water is obviously going to be more expensive. And in spite of this treatment, I think there's more risk of pollution and there's not much flexibility in the control of wastewater. And maybe we never looked at the waste as a resource. Okay. Within a house or say maybe in household, I think there are different things that we can, small changes we can do in design so that we'll be able to control the amount of wastewater. Usually, say for example, if you look at say the different uses of water within a house, using water for flushing, we use say in fact there's wastewater generated from these toilets, and then the grey water is the water that's coming from kitchens and then say kitchens and also from the bathroom areas or shower areas, and then the stormwater. Okay. Okay, the amount of volume of stormwater depends upon the rainfall that you have here. The grey water, usually they're generated from, say, a typical house is around 35,000 to 45,000 liters per year, per person per year. And what is that it contains? Maybe it contains certain chemicals like detergents, okay, and food waste. But in terms of pathogens, it contains very few pathogens and then few nutrients. So treating this grey water, the reason why we call this grey water, treating this grey water is relatively easier when treating this water coming out from the flushes. Okay, this water is actually usually something in the range of 3,000 to 50,000 liters per person per year. So we are trying to mix this with this much quantity. So this is larger and this less. So this larger quantity is less polluted compared to a smaller quantity. So if you can isolate this, you can segregate this wastewater from the other wastewater. And okay, this contains facial matter and fecal matter and then urine. And these two have a lot of nutrients. So this can be maybe used for kind of generating some fertilizers or other things. But okay, you need some kind of treatment for this. But why should we mix this water with this water? Because they are two different quantities. And in fact, many times what happens is we also mix this water in our houses. So all these three are increased. This volume is much larger than this one. So what's happening? The volume of wastewater generated is larger. Okay. So if we can segregate this, so this water can be recycled. In fact, there are a lot of such kind of uh, uh, projects taken up in different as an experimental place in different areas. For example, within our campus of NIT Warangal, we in fact because we have a lot of hostels and messes, we try to segregate the water coming from the messes, a large quantity, and the bathrooms of messes. And this water, we have a treatment system, and then we are treating this water, applying some minimum treatment, and this water is being recycled, and we are using this treated water for flushing as well as for gardening. Okay, so this is something which I think at least to start with, we can start at a community level. For example, a new apartment is being constructed. When you construct new apartment, in the new apartment, you try to have a separate drainage lines for collecting grey water and separate drainage line for collecting this fresh water. This you send it to your septic tank or into the drainage system of the city or town. But as far as this grey water is concerned, maybe you can have some kind of system where you collect it and then have a small treatment system, because it's a community is not doing by individually, a group of individuals, so the cost can be shared and then could be treated and can be used for gardening, washing the common area, or for flushing. You can supply this water, treated water, and instead of supplying the clean municipal water that's coming from municipality or the groundwater that you're pumping, you try to supply this treated water for flushes and use it for flushing. So these are simple things which we can easily do, provided we have that say willpower to do this. So through this, I think we can achieve the control of wastewater, and in fact that is how we can even reduce the amount of water demand that we have. So what we require is a separate collection system for various waters like black water, grey water, and storm water, a decentralized treatment, and reuse of treated effluents, and recycling of nutrients, especially the nutrients produced from the flush water or the water coming from toilets. Okay. So this is how we have been doing. In fact, we use food, energy, water, and then we have elution. Then we have diluted wastewater. We're treating it, and then the treated waste effluent is being disposed into the water bodies, natural water bodies, and the sludge and byproducts are being disposed as part of solid waste. But if we can do some kind of recycling, so you try to have a separate system for this. So you can say collect the stormwater and rainwater and recycle it and start using as for different activities, and then maybe you can actually treat this effluent water, and maybe it can use for producing some kind of energy. At least to some extent, this energy can be used for within the house itself, and this biosolids are produced from the treatment of this highly effluent, say this black water, black water, can be used for as a fertilizer for producing for agricultural activities. Not necessarily within the city, but can be transported and then be used in agricultural activities. Okay. This is how we can try to make it more sustainable. Okay, but so all this is fine, because I think these are not new things that I am talking about today. I'm just trying to, whatever I have discussed today, I think most of you would have heard about from some source or other, because these are things that we've been talking about since at least last 10, 15 years, we've been talking about all these things. But why are not we able to change? There's always a barrier. Whenever we try to change, there's always a barrier. That the barriers could be social barriers. There's a public acceptance. Now, in fact, I just now I gave an example what happened in our campus. We tried to recycle the water and then start using that water for flushing and all those things. Once some of the students started knowing that the treated water is coming to the flush, I think there was some apprehension. So they started complaining that we don't want this water, or they have a kind of a feeling that this water is polluted, so it causes health problems to them. They start complaining that water is say smelling and all such things. So this is okay. There could be some issues, because first time we are trying, there could be some issues. But what we need to do is how to overcome these issues and try to make it more acceptable, but not it should act as a barrier for moving forward. Because we have a kind of a psychological barrier of using when you talk in terms of recycling. And then obviously there's an institutional barrier because I think you need a strong political motivation, which is unfortunately not that much in India. So we need a lot of strong political motivation and a good governance to actually cross these institutional barriers. And then technology barriers, obviously, because present technology doesn't meet this. So as I said earlier, a simple changes in the way we design an apartment or design a house or design our waste collection systems, if you can make some changes in these systems, then I think it's easy for us to adopt the technology to local conditions. We need to develop technology which can be suitable for local conditions, not import technology from others. Okay, you find this kind of studies from occurring in different countries, but you cannot just simply blindly import them. I think we need to adopt these technologies to suit the local conditions. That's where I think our innovation, our thinking comes into picture. And obviously there's a lot of cross-sector relationship, as I was talking about. There's a relation between water resources, energy, and land use. I think this also has to be given, say, importance and attention. And maybe the waste products that are coming into this, so I think they should be used to recycle to satisfy the energy needs. Like I said, we can produce energy from the waste generated, or maybe there are, if you can recycle this, say the waste, solid waste generated, it can also provide certain material needs of the city. And I think again that also requires some kind of say system through which you will be able to improve the way we collect and dispose the solid waste. Okay. So I think there must be more, say, a kind of integrated approach for all these things. So I think a system which was a kind of a culture where you say you try to involve all the sectors for any planning, urban planning, I think is what is needed in our country. And in terms of governance, I think there should be coordination between local, state, and central governments, and then I think public-private partnership would be better. Okay, and obviously we need to develop capacity building. And in fact, I think this is something which, say in India today, as of today, I think 98% of urban India has access to good source of water, but there are quality issues as mentioning, and no city has 24/7 water supply. Why we are not able to provide 24? Because 24/7 water supply will actually has indicated that there will be a reduction in demand. If you can supply water for 24/7, I think the amount of water consumed will be reduced, and we can reduce control a lot of things. But one of the major issues is leakage. If we start supplying 24/7, there will be more leakage losses. So unless we control that, I think we'll not be able to move towards this. And I think most of the cities don't have good sanitation facilities, and flooding in monsoon has become a major problem in most of the cities. This is some of the recommendations made for urban water supply, say by WSS, urban WSS, public-private partnership. Water and sanitation service must be paid to recover costs, and there's more urgent attention needed to ensure sustainable water sources. And I think there must be more investments towards demand management and leakage control and distribution systems. And we have to, I think, renew, say, we have to pay more attention for building, renewing. Yeah, I just, hello?
Yeah, please.
Just 2 minutes where I'll just be winding up. I just tried to borrow certain, just briefly mention about two success stories from different parts of the world. The Cambodia, this capital of Cambodia, in fact, is one of the worst cities, was worse when compared to most of the Indian cities in 1993. But through their excellent coordination, say, they could achieve by 2009, 24/7 excellent quality of water supply. And in fact, it also won the Stockholm Industry Water Prize in 2010. So from 1990 to 2009, 13 years, they would achieve an excellent, say, improvement in the urban water management and could even win a prize. So I think this can be achieved in Indian city also. Cambodia is also a country like India and in fact developing country. So when a country like Cambodia can do it, I think we can do also. And Singapore is another example where it has got a state-of-art integrated water resource management. In fact, they use a lot of advanced technology for water treatment, and they take a lot of measures for demand management. In fact, every drop of water that's put, say, generated, in fact, is recycled and used. So that's what Singapore has achieved. And so to do all these things, I just summarize this, what I've been telling. We need a strong political motivation to adopt this concept of sustainable urban water management in our cities. And there's a need to create more public awareness, to remove the apprehensions among the public about recycling of wastewater, stormwater, and all such things. And obviously, we need to have a change in the attitude across different sectors. And we, as engineers of technologies, I think we also need to look at how to improve our, adopt our technology to actually improve the system management. Okay. So thank you. With this, I'll my talk. Thank you.
Sir, good evening, sir.
Yeah, good evening, Mr. Reddy. Good evening.
Good evening, sir. Thank you so much for your valuable time, sir.
Yeah, thank you, thank you.
I could not join the meeting because I was in meeting, other meeting. That's why just now I came.
Yeah, okay. So
Missed
thank you.
your
Thank
If
you very
any,
much, sir, for just
any
lecture on
questions
sustainable
from?
urban water management. Yeah. This rainwater mostly will be polluted. No, sir. Last lot of pollution will be there with the rainwater, the storm water.
Yeah, in fact, that's what I was mentioning. So that's the reason why we need to go for a decentralized kind of stormwater management system. So if you can actually try to control within the source, at the source itself, the stormwater, source control actually will reduce the pollution, because, say, for example, the water falling within my apartment or within my community, if I can control part of that there itself, I think that will be less polluted when compared to the stormwater which is flowing onto the roads and to the drains, because on the roads, etc. So that's one way we can reduce the pollution of stormwater. And obviously, we need to develop some kind of low-cost treatment technologies where we can have a simple treatment system which can control the pollution, and then we can use it for recycling. So, in fact, that is where I think that's the reason why I'm stressing about decentralized kind of treatment. Whether the wastewater, I was talking about grey water, okay. As far as the toilet water is concerned, it's highly polluted. We cannot have decentralized system. That obviously we have to go for conventional way, collect all this water, and then to have a conventional treatment system. And within city or town, you have this. But I think within the small communities, a colony or a community or a gated community, you can have a separate collection system for stormwater, a separate collection system for this what is called as grey water, the water coming from kitchens and bathroom, and have a decentralized kind of say treatment system and recycle within the community.
Yes, sir. Absolutely, it is required, sir. But our government is not making any policy of dividing into number of zones and collecting the water.
Yeah, that's what I'm saying. Unless we have a strong political willpower, I think these things cannot be achieved. But I think, see, this should be included as guidelines, within the guidelines, at least stormwater. I think at least to examine stormwater, at least when, say, the government is giving permission for the new colonies or new communities coming up with the suburban area of a city, at least they can impose this kind of guidelines that you need to have a collection system, you have to control your stormwater and treat it and recycle it. Unless you do that, you show that we will not give permission for construction. If this kind of guidelines are imposed, I think this can happen, at least from the stormwater point of view.
Yes, sir. Thank you, sir.
So, any more questions?
Sir, my doubt and question, whatever you think. So, urban stormwater management is a major challenge for India, sir.
Yeah, that's right.
Every year we discuss so many things, but again next year we are facing the same challenge.
Yeah, and we are not learning. No, we are not learning from the past. That's what the problem here is. Okay, we try to always make ad hoc decisions, Where today, this year, the problem has occurred, so we try to control that only from as a short-term this thing take. We never think in long-term and see how we can try to avoid this kind of situation in the future. So I think that kind of long-term planning is not there. All our say measures are short-term, ad hoc basis. That's
It's
what I think.
unfortunate.
Hyderabad
One more
last 5 years, 6
unfortunate.
years, every year we are facing, but still
It's
the same
unfortunate
thing.
that number of towns also adding to this list, sir. Like metropolitan cities, urban stormwater failures. Small towns
Uh,
also they are so adding.
yeah, that's right. Yes, yes.
Even in Tirupati, so even a small rain also is inundating so complete streets, low-lying areas.
No, see, this is what I've been. In fact, I think yesterday, I say there was, in this day, there was, in fact, a kind of meeting conducted by Hyderabad Waterworks Association, Waterworks Corporation. So there, they asked me to talk about, okay, it was a 15-minute talk, but I stressed upon the same thing. They asked me to talk about urban floods. So I showed, in fact, I didn't discuss here, but I think your colleague Vinay has done excellent study on urban floods. He has done urban floods and for Hyderabad city. And one other student of mine, he has done on extreme rainfall in urban area in Hyderabad city. So all these results, when in fact I showed them and said, this is the way. In fact, at least you should, when you give permission for new apartments or new communities coming up around the city, at least this is right time for you to take certain kind of learn from this experience, past experience, and see that these mistakes do not happen in the cities that are going. For example, Warangal, I think should learn lessons from Hyderabad and then should see that this kind of things not happen. If you can correct it now, we can improve. We can at least see that it doesn't happen. It can become as worse as Hyderabad. What is happening in Hyderabad or Tirupati? I said because these are all still growing cities. Okay, so at least this is the right time for us to take some measures so that we don't reach that kind of problems that we are facing in
Yes,
large cities
yes,
like Bangalore or
absolutely.
Hyderabad,
The
Bangalore,
list is
Hyderabad, Delhi.
increasing every year.
Yeah, this is at least I think it's the right time for the say all the government sectors to wake up and then take initiatives to see that at least the other cities, second say the second tier cities are say this kind of facilities are improved and we avoid this kind of problems in future. Like what is happening in say Hyderabad, Bangalore, Delhi, all these cities are facing this kind of problems. They all are the same situations. In Delhi, the other day, for example, I think most of you would have seen what happened in Delhi in airport. And I think Bangalore is also another example. So I think this is, we're not able to learn the lessons. That's an unfortunate thing that's happening.
Thank you, sir. Thank you so much, sir.
Thank you. Thank you for giving the opportunity. And I thank all the participants and wish you all the best.
Thank you so much, sir. Hello.
Ishwar sir.
Hello, sir.
Yeah.
So good evening. I'm Rajesh Gopinath.
Yeah, ma'am.
Sir, link 10th, 10th session. I'm not able to log in. I don't know. The
Ma'am?
feedback.
Yeah, don't worry, madam. We will share again.
Thank you.
Yeah.
Thank you.
రాజు గారు అది లింక్ ఓపెన్ అవ్వట్లేదని ఫీడ్బ్యాక్ కామెంట్స్ వచ్చినాయి. ప్లీజ్ లుక్ ఇన్ టు ఇట్ సార్. 10th సెషన్
Yes, sir.
మార్నింగ్ సెషన్.
Okay. Yes, sir. If not able to do it, even tomorrow morning also we will share it. No problem. As tomorrow we will share it.
ఓకే
సార్ నమస్తే సార్. హలో నమస్తే.
చెప్పండి.
హలో
చెప్పండి సార్.
సార్ రేపు ఎగ్జామ్ నేను రాజశేఖర్ని ఎస్వి సెట్ కాలేజ్ చిత్తూరు నుంచి.
చెప్పండి సార్.
సార్ రేపు ఎగ్జాము ఆఫ్టర్నూన్ సెషన్ అన్నారు. ఎట్లా సార్ క్వశ్చన్స్ ఫ్రేమింగ్ ఈ లెక్చర్స్ పీపీటీ నుంచినా సార్?
అంతే సార్. వాట్ ఎవర్ యూ హ్యావ్ లెర్న్డ్ డ్యూరింగ్ దిస్,
ఓకే,
సో ఇట్ విల్ బి ఆన్ దట్ ఓన్లీ సార్. వాట్ ఎవర్ ద కంటెంట్ డెలివర్డ్.
ఓకే. Question, number of questions, sir, either 20 or 30, sir. Is there any idea, sir, on that questions, number of questions.
Should be 20, sir.
Sir? Sir? Question, number of questions, sir, Prasad, sir.
20 questions.
20 only.
20.
Okay. Okay, sir. Okay.
20 questions
thank
అండి.
you. 20 questions, sir?
Yeah, thank you, sir.
Okay.
అవునండి. యువరాజ్ రాజు గారు, యూ కెన్ క్లోజ్ ద సెషన్.
ఓకే సార్.
ఫీడ్బ్యాక్ పంపించారా?
పంపించాను, 10 నిమిషాల ముందు పెట్టాను సార్, 10 minutes బిఫోర్.
సరే సార్, సరే సార్.
ఓకే సార్, థ్యాంక్ యూ.